So let's take this simple example of a ball dropped in the air, and so there's gravity, and this is a one-dimensional problem, so it's only moving in the y direction. So in this case, the Lagrangian is t minus v, which is half mass times velocity squared. Velocity is y dot squared, and then minus mg times y. Okay, so now the equations using Euler-Lagrange are d dt uh, dl dq dot minus dl dq equals the next net external force. So in this case, qj is simply y. Capital Qj is 0 because there's no external force other than gravity, but gravity is factored in v. And so what we need to do is d dt of, well, let me just do these terms individually. So first of all, let's do the easiest one, dl dq, which is dy. So it's going to be the derivative of Lagrangian with respect to y. Now, first expression doesn't have a y, so that's going to be 0. We're only left with minus mgy. And so the derivative of that is going to be minus mg. Okay, so that's one part. The second part is the first term, which is dl d, in this case q dot is y, so y dot equals. So now when we do this derivative, we again treat everything other than y dot to be a constant. So y is a constant, y dot is not a constant. So the derivative of this expression, half m y dot square, is going to be half m. So derivative of y dot squared is 2y dot, because we treat y dot as the variable which we use to differentiate the expression against. And then we have minus mgy, that's going to be 0 because derivative of y, which is in this case considered a constant with respect to y dot, is 0, or the derivative of position with respect to velocity is 0. So we end up getting my dot. Okay, and the final step is d dt of dl dy dot, which is this term, is d dt my dot equals my double dot. So that's the derivative of y dot with respect to time is the velocity, derivative of velocity, which is acceleration. And so now we can plug all these things back into the equation to get so we get my double dot minus mg equal to 0. And so we have y double dot equals minus g, which is the equation of motion for a ball dropped under gravity. Okay, I'll quickly do this in Matlab. Any questions? Let me know. Let's do the derivation using Matlab. Okay, so first TLC, clear everything on the screen, clear all, clears all the variables in the workspace. Um, let's define the symbolic variables. In this case, the symbolic variables are mass, gravity, y dot. That's it. So say real. Let's define the kinetic energy. That's 0.5 times mass times y dot times y dot. Let's define the potential energy. That's equal to mass times gravity times y. And then the Lagrangian, which is t minus v. We save this as course Matlab projectile simple. Okay. Now what we want to do, let me comment these things out. Okay, now let's define the equation. So that's going to be d dy dot minus dl dy equals 0. Okay, so I'm going to define that now. So dl dy equals, so here I need to take the derivative of L with respect to y. Next I need dl dy dot, that's going to be the derivative of Lagrangian with respect to y dot. Then I need d dt of dl dy dot, that's going to be the derivative of what I have here but with respect to time. So put this here. Now if I want to do the differentiation with respect to time, I really did not have not defined time. So the way this goes uh, is the way you define this is, you basically do something like this. D dt with respect to time of any variable, let's say f, is going to be defined as df divided by dx, okay, whatever the variable, in this case y, times dy dt. So that's basically the chain rule. Okay, so in this case, if you apply the chain rule, it's going to be dy times dy dt plus, so since there are two things here, you need to do this with respect to y dot dt. Okay, I just wrote down in a way in which you can understand this. Now I'm going to convert that into variables which are defined here. So this is going to be with respect to y, this is going to be dy dt is y dot, and then we have df dl, so it's going to be y dot, and then this is basically y double dot, which I did not define here, and so it's going to give me an error. So I now define y double dot. Okay, so the equations of motion are d dt dl dy dot minus dl dy. Okay, and see what we get. Okay, so that's the same thing I got by doing the equation using a hand calculation. So basically m drops out and you get y double dot plus g equals 0, which means y double dot equals minus g is the equation. So the same thing comes from doing it symbolically. Okay, so I guess this is the tricky part, which is this is applying the chain rule. I need to apply the chain rule this way. Let's treat this variable. Let's say this is, so maybe I didn't do a good job of explaining it here. Okay, let me just maybe not explain well. So I'm going to retry to explain that. So d dt, let's consider, let's just say that dl dy dot is a variable f. Okay, and what we're trying to do here is we want to find df dt, okay, where f is a function of y and y dot. Okay, so in this case, if you want to do df dt, then it is simply df dy times dy dt. Here's the first part, and then the second part is y dot. But we know that this part is basically y dot, and the second part is simply y double dot. So that's exactly what I wrote here, where dl dy d dot is f. So you can now see how it follows.